Okay, good afternoon, everyone. Good morning to some of our friends who are not on the East Coast or in the Central Time Zones. Welcome to the StorTrends Virtual Lunch and Learn. My name is Tyler Newberry. I'll be your host and moderator for the Lunch and Learn today. With me today is our Director of Solutions, Justin Bagby, who will be joining us in just a moment. But I wanted to let everyone know a couple of things before we got the presentation started. Number one deals with the pizza. So obviously this is a virtual lunch and learn. This is probably a large reason why a lot of you guys registered. So if you are in a pizza delivery zone and you requested a pizza during the registration, that pizza should be arriving within the next few minutes if it hasn't already. Sometimes the delivery person does run a few minutes behind. If they are running late, please just be a little patient with them and be sure to let me know if your pizza has not arrived by the 1:10, 1:15 time frame or so. Email is the quickest way to let me know if your pizza has not arrived on time. My email is tylerin@ami.com. I'm sure all of you guys have gotten an email from me, at least one so far. But again, that's tylerin@ami.com. That'll be up on the screen in just a moment. And it's also going to, I'll also put it in the chat feature in just a moment. But like I said, if it hasn't arrived by 1:10, 1:15 or so, let me know. Number two, please ask questions. We want to provide you an interactive experience for all of you. So feel free to shoot your questions over on the Q&A communicator located at the bottom right-hand corner of your screen in WebEx, and we will either answer your question live on air or we'll send you a message back via the Q&A communicator. And finally, if we do experience any technical difficulties today, though they are rare, but such as losing audio or if the screen becomes grainy for a moment, please bear with us while we fix the issue. Technical issues, like I said, are rare, but as you all know, they can strike at any moment. And they're usually resolved within about 10, 15 seconds or so, so usually not a big deal at all. But anyway, that's it for the boring stuff. That's all I got. Let's get started with the presentation on hybrid and all-flash storage. So everybody, I would like to take this opportunity to introduce our main speaker for today's events, the Director of Solutions for the StorTrends Group, Justin Bagby. Justin, they're all yours.
All right. Thanks, Tyler. Hello, everyone. Welcome to the virtual webinar today that we're having on all-flash storage benefits over hybrid storage. So we're going to quickly jump through a PowerPoint presentation. Not going to spend a whole lot of time on the presentation, and then we'll move into an online demo of one of our all-flash arrays. And in that demo, I'll point out some of the features and some of the benefits of all-flash over hybrid. And then we'll close with a vCenter demo. We'll show you the StorTrends plugin for vCenter for those of you that have deployed VMware and you want to manage your storage array through vSphere, through vCenter. We can do that as well with this product, and so we'll give you a quick demo of that. And then we'll move into a question and answer session. So as Tyler indicated, if you have any questions, feel free to type those into the chat window. We've already got a pretty lengthy list here of questions, but we'll continue to add to that, and at the end of the webinar, we'll answer those questions as they came in. So let's get started. Understanding the landscape. Just wanted to throw up here a small, simple, easy to understand slide of all flash versus hybrid. This is a common question that we get. You know, what's the difference between all flash versus hybrid? So just want to kind of set the tone of the presentation here. A hybrid SAN overview, you can see the right side here, the hybrid SAN architecture. It's going to be a handful of SSDs. It could be NVRAM. It could be just all SSDs, and then it's mixed with HDDs on the back end. The bulk of your storage is stored on the HDDs, and there's some type of a tiering logic that the vendor would use to move the data from the HDDs to the SSDs and from the SSDs back to the HDDs to keep the hot data in that cache or in that SSD tier. So it's a mixture of SSDs and HDDs. The SSDs are utilized for the cache or the tier space. The SSDs are supposed to host all of your hot data, while the HDDs are supposed to store all of your cold data. And then let's move into the all-flash SAN architecture. So this is all SSDs. So you can see below the architecture is a cache plus a tier. What we call that within StorTrends is a write tier versus a read tier. There's different naming algorithms there for different vendors. The SSDs are used for both the cache and the tier space in an all-flash SAN array. So your SSDs hold both your hot data and your cold data. So again, just want to kind of set the tone here of the differences between hybrid and all-flash. All right, so what is it with hybrid SANs? How do they differ? Why are they not all the same? Some vendors use cache, some vendors use tier. Some vendors deploy SSDs as cache only, some use tier only, some deploy both a cache and a tier. StorTrends actually has a StorTrends 3500i hybrid sand that we've been selling and deploying for the last few years, and it uses both cache and tier SSD space along with tier HDD space. So you'll hear a lot of people combat the fact that you don't need cache, you only need tier. Some will say you don't need tier, you only need cache. What we found is that there's a benefit for both, but there's still inherent flaws in a hybrid architecture, and we'll talk about that as we move through the presentation. Some of the hybrid SAN architectures out there, they use NVRAM. NVRAM is extremely expensive for only a small amount of capacity. The most common that you see in a hybrid architecture today is around 8 gigs. That 8 gig space is supposed to land all of your hot data coming in, and it's being cached by the NVRAM card, and then it's sent downstream to the HDDs. And then what are the different RAID sets? Some vendors use RAID 0, in their NVRAM. Some use RAID 1. Others use disk, and they use RAID 5. So it just all depends on their architecture and how they're trying to push data, move data, store data, dock data in the cache. There's a vast majority of different architectures from the hybrid SAN perspective. So why are there so many different architectures? If you think back just 10 years ago, everything was spinning disk. Everyone knew that 15K RPM drives were the fastest. That's what you used for your primary top-end storage, and if you wanted to tier that off, you could to slow spinning 7200 RPM storage and then eventually downstream to tape. But it was a simple architecture. Almost everyone had the same architecture. There were some different methodologies in the way you tier, but we didn't see a lot of different technologies in that tiering mechanism. You didn't see different types of drives. You didn't see, different the levels that are out there today. So why are there so many different architectures? It's because no vendor's been able to perfect hybrid storage. Spinning disk was simple. You need more thick capacity, you add more 7200 RPM drives. You need more performance, you either change your RAID set on your top end, or you add more 15K drives, or you get into a mixture where you've got some 15K drives and 10K drives. But it was fairly simple. You just keep throwing disk at it. So what are the flaws in hybrid storage? Why are there so many different architectures, and what are these flaws? There's multiple inherent problems with a hybrid SAN. The first and foremost is going to be inconsistent performance. So you've probably heard people talk about read misses or write misses. This is usually due to insufficient SSD or flash space. So in an SSD-based hybrid SAN, you have either 2, 4, or 6 SSDs. It's a very small number out of the total, either 16 or 24 that are in the drive set, or you have a very small NVRAM card, an 8 gig card that sits in the front end. So once you fill that hot space up, the data is going to move down. It's going to demote down to the HDDs at a certain level, and different vendors have different tiering policies. But there's only so much data that you can tier at a time. So the SSDs start to fill up. As the SSDs fill up, or as the NVRAM fills up, the next read that needs to come, it's coming off of disk instead of in the hot drive space from the SSD. The next write that needs to come, that's coming into the box, the north side I/O, instead of docking it inside of my cache may be dirty and it's completely full. Now I have to send that write downstream to disk. I have to wait for the write acknowledgement and come back. So we're building a lot of latency here. So you see this increase in latency, and it typically goes from, most hybrids start out in the sub-3 millisecond realm, and as you add data to the box, as you continue to grow that data store, as you add VMs to your environment, and you keep adding applications, and just as you grow, as your company continues to add data, you're going to see that the latency will increase, and it's going to move up, and you'll see it go to 10 milliseconds. And then you may see it spike. You may see it go to 50 milliseconds, 100 milliseconds. It just depends on how long it takes for those write misses or those read misses to complete. And this is just an inherent problem with hybrid SANs, and the only real way to fix this is to continually upgrade your drive. So a lot of you out there today may already have a hybrid SAN, and you're wondering, should I switch to all flash? These are most likely some of the problems you're running into. We talk to a lot of hybrid customers that have had their box for a year, 2 years, and then all of a sudden they're hitting brick walls and they're seeing read and write misses and high latencies. So the reads and the writes go directly to the HDD tier, and it creates these latency spikes. The second piece of this that would be an inherent problem of a hybrid SAN would be growth pains. So it's kind of tied in with number one. You run out of SSD and flash space. So what do? You're forced to upgrade that SSD cache or that SSD tier. It's an unexpected increase in cost. You thought today when you decided to pull the trigger on that hybrid SAN, it was going to last you for the next 5 years, and you find out 24 months later that you're not in a good shape anymore, you're having high latency, and the only thing for you to do is to go from those 400 gig SSDs to 800 gig SSDs and increase the capacity so that you have more space for that hot data, and you're not seeing those spikes in the the latency. The third component here would be product configuration. So the first thing to note is that customers are all different. We've got a couple hundred of you today here on this webinar listening in, and the thing that you need to note is all of your data sets are different. You may be running very similar applications. Some of you are probably running the same applications, but data sets differ greatly. How you access them, how you're utilizing them. So how do you spec the proper SSD cache or the SSD tier and then your cold data on your HDD properly? How do you know that that hybrid SAN is going to meet your requirements today, tomorrow, and 5 years down the road? What's the proper mixture? How do you know how many SSDs to HDD mixtures? The rule of thumb that first came out about 3 years ago, 3.5 years ago, when hybrid was first introduced to the market and it was hot, was you should have 10% of your overall data set in that SSD tier or SSD cache. So if you've got a 30 terabyte box, a 30 terabyte load, you need 3 terabytes sitting in the SSD tier. What happens if you're not typical? What happens if you're a 60% write, 40% read type of an application customer? You no longer fit that requirement. So when they hand you that estimated configuration, it doesn't work for you. You find out really quick that you're starting to fill up the SSDs, you've ran out of tier space, you've ran out of cache space, you're starting to hit the wall with all the read and write misses and the latency buildup. So what happens when your application changes or your I/O load changes? We have a tool that we use called StorTrends iData, and we developed this tool 3 years ago when we were launching the beta product for our 3500 hybrid array. One of the things we realized is that most customers know how much capacity they have. They generally know their IOPS. They've ran some type of a tool in the past, and they know kind of what their IOPS look like. But what they don't know is how much hot data do they have and how much hot data they generate on a weekly basis. So we created a tool that runs in your existing infrastructure called StorTrends iData. You could download it on our website. And this tool will run for 7 days automatically in the background. It doesn't generate an I/O load. And at the end of the 7 days, what we do is we compile a complete report. We watch the blocks that come in on the I/O path. So we're able to identify the hot blocks versus the cold blocks, so we can split up the reads versus the writes versus the rewrites. And we're able to come back to you with a calculated number saying, okay, in this week, you had 400 gigs of hot data, or you had 2 terabytes of hot data, or whatever the case may be. We can provide you with an exact number so that you know today what your hot data looks like. But the question here is what happens when your I/O or your application load changes. We may be able to completely, knock the ball out of the park and hit the nail on the head here and tell you exactly what the configuration needs to be today. What happens in 2 years? What if you add 50 VDI users? What if you add 200 VDI users to this environment? Your load's going to change. Your I/O is going to change. Your hot data is going to change. So how do you handle that if you only have a limited amount of SSD or cache or flash space in a hybrid SAN? And then the final piece here, the point number 4, is data migrations. This is number one, really the most consistent, or I should say inconsistent issue with hybrid SANs. Most administrators and SAN administrators and system IT managers, they think along the lines of the days of spinning disk, when you could just move data from one array to another array. You could, with vMotion, you can just vMotion with VMware environment from one array to the next. With vStorage, there's a lot of movement that you can make on a storage array when it's a spinning disk array. But when it's a hybrid array, you have to be very, very careful how you move that data, how you migrate it onto the array or off of the array. Because every time you touch cold data in a hybrid array, it becomes hot. So you have to understand how that vendor promotes data, how they demote data, the number of cycles they're watching, how many times do they touch a block or what we call a territory before you actually move that data into the hot data zone and then, wherever else it may go. So when the SSDs become full of hot data, let's just say you're going to migrate 10 terabytes from an older, array onto the new hybrid array. If you don't move that data downstream into the cold disk and you just move it straight over into the hot tier, you blow your SSD space out. Your hot data has now been demoted, it's downstream, your cold data is sitting in the top. This hybrid array is in flux. It's going to take you several weeks for it to balance out, and your applications are going to complain, your users are going to complain. It's going to be a mess. So you have to have the right tools in place and to allow the data movement from a spinning disk solution to a hybrid solution, or from a hybrid solution to another solution. So you've got to wait for those data blocks to be accessed to promote up again if you do this, and it allows for terrible latency. So it's not something that you want to get into. So data tiering is slow for most applications for promotions and emotions, and then that causes the application to suffer and your users complain. Now, some vendors build tools in that help you, but you have to be very aware of how those tools work. You have to go through and do some mocks and make sure that they work the way that your data sets look, and then the migration is not going to impede your performance. So these are the primary issues that most customers have with hybrid SAN arrays that have taken them over the last few years. So I started off by saying, that StorTrends has a hybrid array. We've sold that hybrid array for several years now. It's part of our thousands of units that's in the field today. We have happy customers with our arrays, but we have a lot of customers complain. We have a lot of customers that go through and they have concerns about some of the points that I just mentioned on the previous slide. With that, though, I do want to point out where StorTrends performs from our hybrid array perspective. Maybe you are a hybrid array customer, and I'm not saying that everyone is an all-flash array, prospective customer. There are hybrid array customers out there. It still has its place in the market, but one of the things I wanted to point out was our hybrid array performance. If you look here, this was a review done by the StorageReview.com. These guys are out of Cincinnati. They're a non-biased, you can't pay for this report through Storage Review. They take boxes and they publish the results, good, bad, or ugly. So if you have bad performance, they're going to publish bad performance. If you have great performance, they publish great performance. There's not a way to tweak or change or modify this report, and they like to stack boxes up against one another. So you see here, it started with actually 6 boxes. There was a NetApp box that was in this head-to-head comparison as well, and NetApp chose to remove their name and their product from this from the report. But you can see here, this is an 8K, 70% read, 30% write max latency test. And you can see that as they increased the threads, a lot of products started to actually have a hard time with it. You see AMI's has the StorTrends 3500. We're the blue at the bottom. So we've got the lowest latency out of all the products. And we were at consistent latency. And the main reason because of that is because we had both caching and tiering in our SSD array, in our hybrid array for the SSD space. These other vendors either had caching or tiering. They didn't have both. And what we found in our initial testing and development here at AMI is that caching and tiering together would provide consistent performance like this when being tested in a mixed workload at 8K blocks. So let's move into some of the all-flash SAN problems and benefits. So we've talked about the hybrid problems. We've talked about the inherent issues that people are seeing in the field. Let's spend a few minutes talking about the problems and some of the benefits for all-flash SAN. So the first thing that people are going to tell you when you look at an all-flash SAN, it's expensive. Most analysts tell you that the all-flash is very expensive. You're going to break the piggy bank by buying an all-flash SAN. The second thing is the SSD endurance. And we got several questions that came in, when you guys registered for the webinar today. A lot of people were concerned about the endurance, the longevity of the SSD, how many writes can I write to it, when will it expire, what do you do if it expires, along those questions. So SSD endurance is a big problem with an all-flash SAN array. So will those SSDs run out of what we call PE cycles? Those are program and erase cycles. So the analogy that I can give you here is if you basically take a piece of paper and you write a number 1 on a piece of paper, and then I have you erase it with a pencil, and then you write a 2 and I have you erase it, and then a 3 and I have you erase it, and it's all in the same spot. You continue to write. After you get to 15, 16 times, that piece of paper is going to have a hole in it. You're going to eventually erase a hole in it because you've erased it so many times. That's the same way that a SSD drive works with the cell technology inside of it. You can only write to those cells so many times before the cell eventually wears out and it becomes not able to be written to anymore. It becomes a read-only cell. And then a lot of people that are worried about the SSD endurance, they're worried about over-provisioning. Drive manufacturers tell you have so many drive writes per day on the drive, and they had a certain percent of cells inside of that drive. It may be 10%, it may be 20%, it depends on the drive manufacturer. But what happens if a storage vendor starts using that over-provisioning space? And there's some vendors out there that are all flash array vendors. They over-provision the drives. They actually will use the over-provisioned space, which is extremely dangerous because that over-provisioned space was your guarantee. That was your safety net. In the event that you run out of cells, you have a protected layer in there that you didn't know about. It's kind of like if you've ever ridden a four-wheeler, you know, and you run out of gas. There's a great little switch on a four-wheeler. You turn it from, you know, the gas being on to reserve, and now you've got an extra half a gallon of gas to get you back to the, you know, to your house or your trailer or whatever you're trying to go to, you know, to load the four-wheeler back up. So over-provisioning is the same way in SSDs, and we'll talk more about this in the next couple slides. So those are some of the inherent problems with all flash SANs that most people will tell you about. What are the benefits? First is performance. Most all flash SANs, you're going to see superb, you know, 1 millisecond performance. Happy applications, happy users. So you have higher IOPS and you have the lowest latency that's possible. Second is scalability. You can add databases and applications and VDI users on the fly. You no longer have to worry about, you know, do I only have 4 SSD drives in this box that are 400 gigs apiece or they're 800 gigs apiece, and I have an infinite amount, you know, of SSD space here with an all-flash versus, you know, I only had a fixed amount with my hybrid. So you don't have to worry about expanding the applications or adding VMs or growing your data stores. All of it's very scalable now with an all-flash SAN. Less downtime, no failing HDDs. They're not mechanical. So we no longer see flash drives fail. Flash drives simply run out of endurance. You wear a flash drive out, but you don't have to worry about it failing. So if you're replacing hard drives in your existing solution or your previous solution, that doesn't happen anymore. These drives will run, you know, without any problems, any faults. Obviously, we're tracking the number of cells that expire. We're tracking the endurance in the drives in the all-flash array, but you don't have to worry about the mechanical failures or any of that anymore. And then no tiering software. You avoid data movement. So, you know, I was talking earlier about the hybrid of how you have to worry about migrating data. You have to promote it up. You have to promote it down. The data is always moving around. It's always in flux. You know, the data's movement it creates latency when you're trying to move data. You can only move data so much at a time based on the bandwidth with the internal controllers. You may not be able to promote as fast as you need to promote because you're doing data demotion at the same time. So there's a lot of tiering logic in a hybrid that's no longer present in the flash. You're writing across the SSDs, so it helps you avoid the data movement. And then data migration and movement resolve. We just talked about that, how with an all SSD array, you don't have to worry about flooding the box out because you're simply migrating the data to all SSDs. So there's no longer a SSD mixture in this array. So the StorTrends 3600 series, the all-flash arrays from American Megatrends, it doesn't break the piggy bank. So how can AMI provide an all-flash SAN array at hybrid SAN price points? Well, there's two reasons. First and foremost is the deduplication and compression. So we elected not to put dedupe and compression in our StorTrends 3500 hybrid. The reason is because of the overhead involved with it. Anyone that tells you that deduplication and compression doesn't have an overhead, they're absolutely lying to you. There's a penalty for running deduplication and compression. But there's also a way to architect it to make it as fast as it can possibly be without completely hindering the performance. So we elected to add deduplication and compression into our all-flash array. That allows us to go from a 1.7x, that's our minimum. The 0.7 is basically just compression on top of any of your files or any of your data that you already have, and then deduplication is on top of that. So compression alone is 1.7. What we're seeing in most of our boxes, our typical IT environments, are at a 4-to-1 data compaction ratio. That's deduplication and compression engaged at the same time. And then the next point is the mixed all-flash tier. So we mix a write tier with a read tier, and this allows us to get more capacity out of the box. The write tier drives that are out there today, they're limited in capacity. The largest write tier drive that you can buy that is an enterprise class write tier is a 2 terabyte drive. But the largest read tier that you can buy is a 3.8 terabyte drive. So we mix these drives in order to get the capacity higher on the read tier while still offering the performance needed across both. So the write tier drives are enterprise SSDs. They offer 10 drive writes per day. So these are your very expensive SSDs. They're very, very high cost SSDs. The read tier are the read enhanced SSDs, and they're 1 drive write per day, and they're lower cost SSDs. Now, The reason that we can offer a mixed tier configuration here, a write tier versus a read tier, is because of a patented algorithm that we have called in-lift cache. This is what we use to protect the endurance of those read tier drives. You notice that the write tier drives, the enterprise SSDs, are the 10 drive writes per day. Those are your enterprise SAS SSDs. So that means that I can take the capacity of that SSD. Let's go back to the 2 terabyte drive. It's 2 times 10, so that's going to give me 20 terabytes to write to that drive per day. So every day I can write 20 terabytes of data to that drive. That means the 2 terabytes can be programmed and erased, and 20 new terabytes can be written to that drive on a daily basis, and the drive manufacturer guarantees that for 5 years. So we pass that along to you and say, okay, we're giving you 5 years of endurance guarantee with this box. For 5 years, you'll never run out of writes for the write tier. But what do we do about the read tier? It's only 1 drive write per day. So if it's the 3.8 terabyte drive, that means I can only write 3.8 terabytes to it. A lot of you that are on this webinar today, you may blow through that considering your data set. So what do we do? How do we control that? You know, if we used all write tier drives in the array, the price of the array would be insanely expensive. But by offsetting it and using the read tier, we can reduce the price, and it becomes, you know, very favorable from a value perspective. So the way that we protect those read tier drives is with what we call in-lift cache. It's a small section that sits within the write tier, so it's a section of the write tier drive that we carve out, and any rewrite that comes into the box that's supposed to go to the read tier, we dock it in in-lift cache. And we collect those blocks in lift cache, and then we make one consolidated drive write downstream to the read tier. So that way we're only performing that drive write 1 time per day or less. So this is how we can also guarantee that for 5 years. So the read tier will never expand, the read tier will never go beyond the 1 drive write per day, and we won't blow through the 5-year guarantee. So when you purchase a StorTrends 3600i or a 3610i, there's a 5-year guarantee that it will never run out of endurance. So if you look at the illustration on the right, you'll see the top section here. This is our reads and writes from the SSD tier. So anytime that a read, which is the blue block, is requested, it comes directly off of the read tier. So just like with your spinning disk used to be, it comes directly off of the disk. It's extremely quick because it's all SSDs. These are all 50,000 IOP SSDs that are in this box. But a write goes directly into the write tier. So what happens if there's a rewrite that comes to the blue block, the Z block? Well, that's the next section down, so move down to the next little picture here. And the illustration here shows that the write data, which is Z, instead of it going directly into the read tier, we send it into the in-lift cache, and it's docked there. It might sit there for an hour, it might sit there for 24 hours. It just depends on the number of rewrites that you have coming in for the blocks that are already existing in the read tier. And then we perform one consolidated drive write from the in-lift cache down into the read tier 1 time a day. So this is the way we don't blow those cells out of the read tier, and this is how we can guarantee a 5-year endurance for the StorTrends product array. So with these 2 technologies, with the deduplication compression and the in-lift cache allowing us to do a mixed all flash tier and a write tier and a read tier, you don't have to break the piggy bank. So this is our strategy of how we've been able to bring value to this product to you. So here's our slide on all-flash array versus hybrid pricing. So this is where the rubber meets the road. So let's compare an all-flash array to a hybrid array, and let's look at a user set of 30 terabytes. So on the right in the red, you'll see the StorTrends 3500i hybrid SAN. This is a 63.3 terabyte overall capacity solution. So again, remember, this is a mixture of 4 SSDs and 12 HDDs. Now we're going to put those HDDs in a RAID 10 on the back end. In the event there's any type of a read miss or a write miss, we're going to end up in a RAID 10 on the back end versus a RAID 5 or a RAID 6, which would be just extremely slow and it would bring the system to its knees. So the 63.6 terabytes is going to reduce down to 29.47. We're going to have a little over we're going to have around 2.88 terabytes in hot data on the SSD space, and the remainder of that, the 27 terabytes, are going to be in the HDD space. So our dedupe ratio and our compression ratio are 0 because we don't have dedupe and compression in this box. The latency is going to be around 3 milliseconds. It's going to throw around 100,000 IOPS, It's going to use 3U of rack space, 5,028 kilowatts per year of power, and the CO2 emissions are going to be about 3.5 tons. So if you take the total capacity and you divide it by the street price of $35,880, you come out to $1.18 a gig. Now let's move over to the left and look at the green. This is the StorTrends 3600 IL flash sand. So this is a 16 bay, it's all flash drives. The raw capacity is going to be 12.3 terabytes. The usable capacity is going to be 30.6 terabytes. We used a very conservative 2.6 dedupe ratio, so a 2.6 to 1 is our ratio that we use for this box. The compression ratio is a 0.7. So our hot data capacity, it's all hot data. It's 30.6. We don't have HDDs in this box, so it's all hot. It's all on flash. The latency is sub 1 milliseconds. The IOPS are going to throw around 200,000 IOPS in this configuration. It's 3U rack space. You'll notice the yearly power is a lot less because the SSDs draw much less power than the HDDs, and they also put out less CO2 emissions because of the power consumption reduced. So you've got 2.3 tons of CO2 emissions. So if you take the total capacity and you divide it by the street price of $36,984, you come out to $1.18 a gig. So the question that we're asking our customers now is, with deduplication, with compression, with the ability to do our in-lift cache and the mixing of the write tier and the read tier, why would you buy a hybrid sand when you can get an all-flash sand for the same price? So this is the message that we're taking to the market, and this is what we want to resonate with you today in the webinar. So we used a 30 terabyte example here in the slide deck. Maybe you're sitting there and you say, I've only got 5 terabytes and I'm a small shop, or maybe you're saying I've got 200 terabytes and I'm a lot larger shop than that. How does that apply to me? Well, you can get that online price quote through our online price quote generator. If you go to StorTrends.com, you can see that there's a tab there that you can click on that'll take you to the online price quote generator. You fill out your capacity, you put in your IOPS, you put in your interface type. If you know your read to write ratio, you can put it in. You select your application types, your support level, and your support term, and we're going to provide you with an online price quote. So that's emailed to you following filling out that online price quote generator. This is going to provide you with a list price, and it'll provide you with a street price, just like we showed before. So that way you can kind of weigh, what is this going to cost? What's the cost of this configuration without getting involved with a sales rep or with a solutions engineer. If you just want to know what it would look like, dollar and cents wise, you can go here and get an instant price quote. All right, so let's spend just a few minutes talking about who do we sell to. So some of you may have heard of us today, some of you may have never heard of us. American Megatrends Incorporated has been around for 31 years. You've probably heard of us from either our RAID cards or our system level BIOS. Those are probably, that's the number 1, number 2 product you've probably heard of us from in the past. We were the largest RAID company in the world from 1995 until 2001. If you've ever used a Mega RAID controller, if you've ever used a Dell server, if you've used an HP server, Sun, everyone except IBM. IBM owned a competing company called Milex, and they sold Milex RAID cards. But all of the other Tier 1 and Tier 2 OEMs worldwide shipped the Mega RAID controller, and that was an AMI, an American Megatrends product that we launched. That was our initial intro into the storage market in 1995. We sold that off to LSI Logic, and now that's part of Avago. So if you use that same Mega RAID card today or Mega RAID controller down on your server, that is an American Megatrends designed and created product. The other product is our system BIOS. There's about a 80% chance if you reboot the computer that you're watching this presentation with today, when you reboot it, you're going to see an American Megatrends logo on the screen when the BIOS posts. That's the system level BIOS inside that computer. So we've got a little over 80% of the total BIOS market. Your servers, your workstations, even your storage arrays. We're on most of the storage arrays that are out there that are x86 based. But your desktops, your tablets, everything, embedded devices, anything that's an x86 architecture, we have a very large footprint there. We own that market in regards to system level BIOS. And then there's an entire gamut of products you've probably also heard about us from, but those are probably the 2 most common. So back to the StorTrends division. We launched this division in 2004. We used the same group of engineers and management that created the Mega RAID controller for us that got us into the storage market as the #1 RAID vendor, and we deployed StorTrends. So over the past 12 years, We've been able to ship thousands and thousands of these systems worldwide. We're in all types of target markets, from education, advanced research, financial, healthcare, manufacturing, high-tech, legals, retail, service providers, small enterprises, government, both private, public sector, and federal. So we're in just a slew of verticals. And people ask me all the time, you know, what niche do you cater to? We don't cater to a niche. We sell centralized data storage. Now, that doesn't mean that we don't focus in some areas. We have 3 of the top 5 radiology companies in the world using our product, and they all use an application called Imagine. That's a application that tracks their billing, patient records, patient visits, their appointment settings, their scheduling for their radiologist. It controls everything that the radiology company would use to run their business. We integrate with that, we test with that, and so there's certain things like that that we are focused on, but we primarily, our drive is to provide centralized storage to anyone that needs just a handful of terabytes up to 250 terabytes. That's where we focus. So we call that the small to medium business and the small to medium enterprise, and that's where we typically play. Here's just a really quick slide of some of our existing customers. You can see that this is just kind of a slide to show you all of the different niches and the different markets that we actually fit into. You'll see here that there's legal, there's medical, there's transportation, there's education, there's finance. You name it, we've been installed in it. So just wanted to quickly share with you a report that came out just a couple months ago. It came out in September of 2015. DCIG did a ranking of the all-flash array vendors. So they send a survey out, they ask you a whole bunch of questions, they get on the phone with you, they kind of pound through your product, they want to understand, you know, how your technology works, and then they weigh those against all the other, you know, products that are out there in the market. While we didn't receive best in class, we were in the excellent category. So if you look at this, there were 29 all-flash array products that were ranked in this, and we were ranked excellent. We came out 4th in this report. So you can see here the StorTrends 3600 has a lot of the features that some of the bigger name guys that you're probably very familiar with or you may have used in the past have. And that's one of the things we wanted to point out here, that the biggest differentiator that they saw was the mixed write tier and read tier with the in-lift cache. They felt that that was extremely important because it provides a lot of value in the product that the other vendors didn't think about when they were architecting and designing their product. All right, so quickly we're going to jump into a StorTrends major features. We're going to talk some technical stuff here. So what are some of the main components of the StorTrends ITX? The ITX is our operating system. This is what's inside of the StorTrends 3600 or the StorTrends 3610. When you purchase it, it's our software that we sell with the appliance. It offers thin provisioning, inline deduplication, inline compression, advanced snapshots, the in-lift caching, replication, what we call RAID RT, which is our software RAID, and then auto data tiering is also in the box to move from the head to the JBOD. So what are some of the technology benefits that we've brought to the table here? Obviously, inline compression and deduplication for superb space savings. We talked a little bit about that, and in a couple slides, I'll give you a little bit more information about how the dedupe and the compression works. The read and the write tiers, we talked about the different tiers, the different types of drives that are in those tiers. And then in-lift cache, we talked about that and how we use that for the endurance of our product. That's how we guarantee 5 years of endurance on those drives that you won't have to touch them for a 5-year period. And then an important point here is we have over 100 configurations based on different drive sets and drive types to give you the performance and the capacity at the price that you need. So if you're one of those customers that has your high reads and low writes, we absolutely have a configuration for you. If you're a customer that's the exact opposite and your high writes, your 90% writes and 10% reads, we have a configuration for that as well. So we don't try to paint you into a box, you know, and only have 3 or 4 different configurations and make you swallow what we're trying to sell you. We actually give you the flexibility to mix and match the configurations that you need, you know, with the proper performance and capacity and price to meet your exact requirements. So we're not feature-based licensing. So some of our other competitors are feature-based. They charge you for different pieces of the licensing. We are all-inclusive. And then complete VMware integration, the VAI support. We support all the VAIs, both the mandatory and the optional primitives that are there. So software performance, superior latency reduction. So we're sub 1 milliseconds. And then we talked about the data compaction, the data deduplication and compression. We actually have configurations that range under $1 per gig and go up from there. So it just depends on the mixture of the write versus the read and the number of drives that you need to get into that calculation. And then we're targeting high-performance databases, mixed workloads, VDIs, and virtual environments with this application. This slide just kind of points out the evolution of the StorTrends product model. Just want to take a couple seconds here and explain this. On the far left is the StorTrends 3400i. This was our spinning disk solution. So this spinning disk solution would scale up to 256 terabytes. You would have a head and you would stack multiple disk enclosures under it. You could tier the data, so you could go from 15K drives to 10K drives to 7.2 drives. You could move the data around as needed. We had some tiering, tiering logic in here that we call information lifecycle management. It allows us to auto-tier the data. That box was released about 7 years ago, and if you start moving to the right, you kind of see how we evolved. We moved into the StorTrends 3500 a few years back. This was our hybrid solution. This is where we put either 2, 4, 6, or 8 SSDs in the front end of a hybrid array, and then the back end is mixed with either SAS drives or with SAS or NL-SAS drives to grow that box out capacity-wise. And then to the right are the two boxes we're talking about today, the 3600i and the 3610. Both of these boxes were released last year in 2015. We have these boxes in the field. The difference between the 3600 and the 3610, the 3600 scales up to 64 terabytes, the 3610 scales up to 256 terabytes. The reason that there's a difference in the two boxes is the cores in the CPU and the amount of memory. If you're a 5 or 8 terabyte facility, and that's all you really need is 5 or 8, 10, 12 terabytes, you know that you'll never grow beyond the 64 terabytes. You don't need the CPU horsepower or the memory that's in the 3610. So we viewed that as a wasted cost that we would have to pass on to you as the end customer. So we decided to lighten that, and we reduced it down to 16 cores and 64 gigs of RAM. That allows us to provide more value to you as the customer. And it reduces the system price so that you're not swallowing the bigger model that you may not need. But if you're a customer and you've got 40 terabytes or 50 terabytes today and you know you're going to go above that 64 terabyte threshold, you would need the 3610. It's got more CPU cores, it's got more memory. That's to help with the deduplication, the compression as you grow that data and you move from, the 64s up to the 256 terabytes. So that's the reason that there's two different models here. So this is an eye chart, and we're not going to go into depth about it. We're just going to touch just a couple things here. We are VMware partner. We're a Technology Alliance partner. We're a TAP Elite member. We're Citrix certified and Citrix ready, and we're also a Microsoft Gold partner, and we're Microsoft ready. So this box will work with VMware, it'll work with Citrix, and it'll work with Microsoft hypervisors. You can have one of those, a combination of those, and we're currently qualifying with Red Hat's RHEL right now as well. We are VMware certified. We support all the VAI primitives, both the mandatory and the optionals. And then we'll talk a little bit about snapshots and replication here. So advanced snapshots, we support VSS, so we're VSS aware. We can take 8,096 snaps. We can schedule those to the minute. You can mount those snapshots, review those files. You can do single file level recovery, or you can roll the entire snap back. We use those snapshots for our replication as well. So those snapshots are redirect on write. We just redirect the snap to the next available storage space. In the array, we don't make you set up a 20% or 30% area to save for snapshot space. We just reclaim the next available block, write to it, and move on down the road. We use that for our DR strategy. So we have a package called WDS. This is Wide Area Data Services. We'll perform data dedupe, compression, encryption, and then we'll do WAN optimization across the wire when we're sending those Delta snapshots from your primary array to your secondary array. This allows us to speed up the amount of snaps that can be sent. It allows us to use a smaller bandwidth, and it allows us to keep the secondary box in line with the primary. So we're always up to date. In the event that the primary fails, you can fail over to the secondary, and all of your data is in sync and ready to go. So it's a really unique feature that we have a lot of patents around. And then we're going to just kind of jump from here. We're going to keep going. I talked a little bit about this next slide, StorTrends iData tool. You can download this from StorTrends.com. This is a tool that I said runs, it runs really quickly. It takes just a few minutes to set it up. It auto-discovers your servers. You can either kick those servers out or you can add new servers by the IP address. Once you select the servers that you want to monitor, you can do this at the physical layer, at the server layer, or you can do this in the VM layer. So you can do this based on VMs through vSphere, or you can do this at the physical server layer. It runs for 7 days in your existing environment. And what it's going to do is it's going to calculate the capacity used during that 1 week period. It's watching the ops, the reads versus the writes versus the rewrites. It's watching the network utilization, the bandwidth. It's going to monitor the system performance. And you can see on the right over here, this is kind of the overall summary. It rolls up a nice report like this for you that allows you to kind of understand what it monitored during that 7-day period. We're not running any new tools, any proprietary tools here. We're plugging into your VM environment. We're using your Windows WMI that's already there in your Windows servers or your Windows systems. We're monitoring all of those tools that are already there. So we're not adding anything. We're just collecting everything. But the biggest piece of this is we're going to identify the hot versus the active data versus the cold data. So you're going to be able to see at the end of this tool, at the end of this report, you're going to be able to understand during a 1 week period how much hot data does my company actually drive and how is that compared to my cold data. A lot of customers like to run this tool once or twice, maybe even 3 times to get different week perspective as they're kind of moving through, depending on if their business is seasonal or whatnot, to understand, you know, how much hot data do I really have? Is it a terabyte, 2 terabytes, 20? So they get a good feel for what they've got going forward. We also have a StorTrends dedupe analyzer tool. So a lot of you that are on the call today, you're probably saying, okay, what's the dedupe ratio that I can expect? I know I heard you say 4 to 1 is what most of your customers get. What happens if I'm not one of those customers? What happens if I'm in a 2 to 1 ratio? You know, or what if I'm really, you know, I've got a lot of VDIs running on this thing, and I've got a lot of cloned images. I've got a lot of, you know, consolidated backups that we're going to throw on this thing that we just need to keep one image of, where today we've got 3 different backup points of that. You can run this dedupe tool across those databases, and it's going to provide us with an indicator of what your dedupe and compression ratio looks like. So it runs on backup or unmounted data. The one caveat here is you cannot run this on an active database. Our dedupe analyzer tool does generate load. It is calculating the data blocks that it's watching when there's duplicates, so you don't want to run this on some type of an SQL active database that's mounted. You want to either unmount it during when you're doing some type of maintenance mode, or you want to run this on a backup. And you don't need to run this across your entire data set. You can run this just on a few, a little small slice or portion of your data set. That's all we really need to understand what the average is going to look like. But it compares the data blocks for the dedupe savings, both for compression and dedupe. So it's going to analyze this. It's going to provide us with the number at the end of the day. And then what it's going to allow us to do is ensure proper all-flash configuration. We know what the write tier versus the read tier looks like, and then we can allow you what your budget looks like for capacity growth. You're going to know, based on the way that you're currently, your business is running today, a year from now, what is my capacity going to look like based on the data that I'm deduping now. All right, so we're going to jump into a demo here. So let me move this over. Give me just a minute. I'm having a system hang up here.
All right. Well, while we're getting ready to set up the demo and everything like that, and Justin's getting going here, we're going to dive into just a couple of quick questions that everyone has sent in, with your registration and everything like that. So the first question comes to us from Lena, and Lena asked, how does the longevity of SSD compare to spinning disk in terms of write exhaustion? Also, what is the return on investment on moving all storage to flash when considering long-term data storage, while where performance is less of a concern? So kind of actually a couple of questions in there, but I'll let Justin answer a piece of this with asking how the longevity of SSD compares to spinning disk.
Sure. So we touched a little bit on this in just a few minutes ago. So with spinning disk, obviously you have mechanical pieces in there. You have head movement, you have needle movement, where you're doing seeking in and out of the platters. You have head movement that's moving up and down the different platters. All of that movement is something that can break. Obviously, it's all magnetic as well. Something could happen to a bit that's on the drive. So with HDDs, we do see failures. You probably see them as well, Lena. So HDDs fail. We've seen them fail over the years. Most of the time, it attributes to some type of either a non-medium error buildup on the drive, or it could be a physical or mechanical issue with the drive. With SSDs, we do not see that at all. We've been running SSDs and testing SSDs now for over 5 years. Even in our hybrid arrays, our SSDs, they're not failing. They don't fail in the field. What happens to an SSD is it runs out of endurance. There's only so many programming array cycles that it can have in the cell, and then eventually that cell is going to wear out. So I'll show you here in the demo in just a few minutes how we track that endurance, and I'll explain a little bit more about how we can notify you as the endurance starts to wane on that drive. But with a StorTrends array, again, I just want to reemphasize here that for 5 years you will not have any endurance issues out of these drives. That's because we've taken the extra measure to create the extra technology in the inlet cache to protect those drives. So Tyler, we'll come back to some questions here in just a few minutes. I just want to quickly jump through the demo. So when you log into a StorTrends 3600 or a 3610 array, this is what you're going to see. If you have multiple arrays that are here, you can manage all of those arrays. You can see there's multiple arrays here at the top of the screen. You're going to log in and you're going to see an initial StorTrends statistics page. This is going to show you excuse me, this is going to show you your physical capacity. So this box has 4.55 terabytes. It's got a predicted capacity of 31.64. So how did we arrive to that? I've put 165.84 gigs of data on this actual box. Sorry, I've actually put 1.13 terabytes of data on this box. We've been able to reduce that with our data technology, our data reduction technology. This is the dedupe and the compression, down to 165.84. So if you take the 1.13, or if you take the 165 and you divide it by the 1.13 terabytes, you'll see that that's a 7x savings. So with the data that I have here, and I have some VDI stuff running on this and a lot of virtualization environment, so I'm able to get a 7-to-1 ratio. So we can predict the free space. You're going to have about 30.51 terabytes. You're using about 4% of your space today, so you've got about 96% that's available. And then this shows your physical space. So if you're worried about the actual physical space, you can see that 4% has been used and 96% is available. So let's just kind of move down the screen here. And again, this is the home page when you first log in. So it's going to take us into our latency charts. So this has got some I/O running on it right now, so you can kind of see where I'm looking at my I/O, and you can see what the latency looks like. So you can see how the latency will move up, and then you can see how the latency will move down. So you can see that the latency is graphed over here on the right. This is telling me my instantaneous, and this is telling me my average. And you just saw it update. So it updates itself every 5 seconds. It'll repoll. So this is just a good way to understand exactly what's going on in my array today. So this is the storage level latency. This is the storage level IOPS, and this is the storage level throughput. And then at the bottom, it's going to tell me a little bit about my I/O sizes and my average read-to-write ratio. So this just kind of breaks up what's coming into the box today. So I know that we only have a few more minutes, so I'm just going to kind of hurry through this. So we have an event log. I'm just going to kind of go down the tree here. So this is where all of your events are logged. You can decide what type of events do you want. This is the I is for informational, the yellow is for warnings, and the red is for fatal or critical events. So if you have anything that happens to a NIC, if one of your NICs goes down, you're going to see that considered a fatal event because we've lost an I/O path to the box. So it's going to have some degraded performance. And actually with our array, if a NIC fails like that, we're actually going to fail over seamlessly in the background. The applications don't know this, you don't know this, but we run off of the other controller, which has a full path coming to it, so that we can maximize performance while we're alerting you that the other NIC is down, so that we can either switch the ports if a port died on the NIC, or if the cables got unplugged, somehow it accidentally got popped out when somebody was behind the cabinet or whatnot. We can get that addressed, and then we can fail back over at a later point in time. But this is where we gather all of those events, so you can see all the events here. You can kind of scroll through them. You can elect what you want emailed to you. If you only want the fatals emailed to you, you can have that. If you want the warnings and the fatals, you can have that. If you want to be flooded with all the events, we can do that as well. And then we monitor these events here in Atlanta, Georgia. So we perform 24/7 monitoring of these events live. We watch these events, and then we tell our customers what's going on in the event that they're occupied with something else. So a lot of times we're doing predictive failure analysis on these boxes, and we're receiving warnings that are telling us, you know, that, hey, this looks like this, you know, the temperature on this fan has gone up, and this has crossed a warning threshold. And that way we can go ahead and contact the customer, schedule a window to go in and take a look at that fan if there's something going on with it. Just kind of moving through the demo here, hardware health, the next page. This is something that's very different for our box as compared to the competitors. You actually get to see a graphical image of the box. So you can see here, this is a 3U 16-bay box. You can hover over any of the drives that are in this box, and you can see the output below. You see the serial number, the slot, the capacity. You see what type of drive it is. You can see if it's online, if it's healthy. You can see the outside drives here are our right tier drives. So you see there's 2 drives on the outside that are our right tiers that are marked with the gold star, and then all the drives in the middle are our read tier drives in this array. It'll tell you the statistics of the CPU and memory utilization. You can see that this is the active controller on the left side. The right side is the passive controller in this configuration. That's the reason that the memory and the CPU usage aren't as high. And then as you go down, you can actually see the I/O that's here. So you can see the network utilization that's coming in. You can see what it looks like for both controllers and compare them, as if it's in an active-active. We can also do active-active as well. Just want to quickly keep going through this. This is our software health information. This is where you come in and you can actually check the software health. The management console, if you wanted to manage this by CLI, if you're not a GUI guy and you'd prefer to manage all of this via CLI, you can absolutely do that through the management console here, or you can have your own putty session into the box. Dashboard, this is where we control the box. This is where we do all of our updates. This is where we handle everything that we do our setup-wise for licensing, for users. This is where we generate our debug dumps. You can click one click on the debug dump. It'll generate a debug dump for both controllers. So if you want us to take a look at something on our side, maybe you have some latency buildup on one of your volumes and you're unsure why, we can dig into that for you here, or you can take a look at it on your own through some of the tools that we offer in the box. Just want to kind of go through this. I know we're really pressing on time now, but you see that you have a right controller and a left controller in the box. We talked about the storage statistics. Here's the storage volumes. This is kind of just what a volume looks like. I've created a lot of demo volumes on this box just to kind of show you what's going on here. So you can see the map size is 0.46 gig in this box. The available space, this is thin provisioned out. So you get to set different settings for your volumes when you're creating them, and then this is where you manage your volumes as well. So again, just giving you kind of a peek of what the GUI looks like from a managerial perspective of the array. All right, and then just want to kind of go down and talk a little bit about some of the stuff at the bottom. So you see here, this is the configuration portion. Everything in this box is wizard driven. The reason is we want it to be simple to use. We don't want you to have to come in here and try to remember how do I do this or how do I do that. Everything's wizard driven, from storage wizard to be able to modify the storage, from volume wizard, volume creation, to setting up the networks, the aliases, the virtual IPs, and everything in between. We talked a little bit earlier about replication. So I'm going to jump now into a separate demo, and this is actually this is our vSphere plugin. So anytime you log into vSphere, obviously all of you know what vCenter looks like. You probably use it on a daily basis. This is our StorTrends plugin inside of vSphere. So this is what the Getting Started tab looks like. We move over into the summary. Here's where I can see everything that's happening. So just kind of going to jump through these really quick. Here's your storage statistics. This is the latency piece of this. We have plugins that allow us to go into the volume statistics, and we can actually drill down into those volumes. We can drill down into those VMs. So if you've got a specific volume that you want to look at, or a virtual machine, you see we have our volumes, we have our data store, and we have our virtual machine. You can click on any of these at any given time, and you can actually focus in on what they're doing. So I don't have anything running on those 3 virtual machines right now that's there. There's the data store present, so you can hone in, and then we can drill down in this and actually give you an indicator of what's going on with a specific volume, a data store, or a VM. So if you're looking for some VM control, you want to understand more about why VM may be spiking latency and other VMs aren't, this is where you would start. This is where you would actually dig in, and then you can manage everything in the storage from this one screen. So if you want to create a virtual machine, if you want to clone a virtual machine, if you want to expand a data store, if you want to delete a data store, or if you want to set up snapshots, on a volume basis, we can do it here as well. So just a real quick overview. I know it's really quick, but just want to show you what the vSphere plugin looks like. So now I want to turn it back over to Tyler for the last few minutes here and go to some Q&A stuff.
Very cool. Thanks so much, Justin. Like Justin said, we've only got about 2 minutes or so left here. So I just want to run through these last few questions really quickly. This one came from M. Jackson. One question we had was, the question he asked was, can you store and replicate off-site? If so, what is your support and what is your time to restore? So I'll go ahead and take the first part of that. Absolutely, you can store and replicate off-site to another StorTrends array. And the great thing about that is, and I think Justin touched on this a little bit earlier, was that if you have an all-flash array in your primary location and your secondary location does not necessarily need to be high performance, if it's just cold data, backup data that's just going to be sitting there that you just need to have for archival purposes, you can actually purchase an all-spinning disk array from StorTrends and replicate to that. Not a lot of vendors do that. As far as the support, we've already kind of gone through that to a degree, but great support, all based out of Atlanta, Georgia.
Yeah, I think that question, Tyler, is what is your support? They're talking about recovery point objectives and recovery time objectives there from the replication side. So within the StorTrends array, we can set up different levels of replication. We replicate the snapshot level, so we can do it as granular as 1-minute intervals and send that over. We only take the deltas from the snaps. We also have a periodicity setting inside of the replication package where you can decide when you want to replicate. If you don't want to replicate during heavy traffic times, maybe you have 2 identical facilities and you're sending data across that wire back and forth between the facilities from an application level. Obviously, you don't want to bog that with your storage. So we can decide and set that at different levels. We can set it at different times to replicate. We've got catch-up where if you want us to come through and really replicate hard between 2 and 4 a.m. when there's not a lot of traffic on that line, we can set the periodicity to replicate during that time. There's a multitude of replication settings here. Replication was our bread and butter that we sold on when we had our StorTrends 3400 spinning disk array back about 8 or 9 years ago. So this is something that we've had for a long time, and it's something that's very valuable in this product. And as Tyler indicated, you can replicate from an all-flash array to a hybrid, an all-flash array to a spinning disk, or we can do a hot, where we can go from an all-flash array to an all-flash array.
All right, sounds great. Like I said, last few that we're trying to get to here that came in towards the end. When a hard drive does go bad, and I guess in this case might mean an SSD, is it replaced via warranty?
Yeah, absolutely. Yeah, we offer a 5-year warranty guarantee on endurance. So at any point during that 5 years, that SSD expires. If there's any type of for some reason, if it happens, it's not going to happen because of our technology that we've implemented. But let's just hypothetically say that it does, and it runs out of endurance, we replace that drive free of charge.
Very cool, very cool. And can the appliances be linked together? This is from Thomas. And if so, how many appliances can be linked together?
Yeah, so the appliances, as I showed in the initial screen, at the top you can see where you can manage them all together. They cannot be linked together, meaning can you do horizontal expansion? The answer to that's no. We scale out via disk shelves underneath the head instead of going horizontally. So they're not linked together horizontally, but they are. You can add additional performance and you can add additional capacity by stacking with additional shelves.
Great. And another one from Thomas, does the console send notifications? I'm guessing if there's some sort of error going wrong or some sort of failure or something like that.
Yeah, absolutely. We do. We notify. We do it through email alerts. We also have SNMP traps, and we can provide you with a MIB file if you've got some type of a management device that you're using to manage all of your servers and your storage and your environment. We can give you a MIB file that we plug into that'll tell that centralized manager of the alerts of the system. Yeah, absolutely.
Great. And last question that had come in off registration was from Tim. Tim asked, do you offer a proof of concept that we can test in-house before having to buy the all-flash array?
Yeah, absolutely. It's one of the things that we stress a lot of our customers to do. We like for you to test the technology before you buy it. That way you know what you're getting. We're comfortable with your environment. You're comfortable with our product. We set that up for you remotely with one of our solutions engineers. We go through and help you understand kind of how the box works, all the features of the box, and then you get to test it for 30 days. You can put a backup, images on it. A lot of our customers move live data on it and test it live. You can do that as well. But it's a 30-day proof of concept. It's a simple 2-page agreement that you fill out. That just basically says if you kill the box, you buy it, but if you don't like it and you want to return it in working condition, just send it back, no questions asked. So we're very lenient when it comes to proof of concepts.
Very cool. Well, I think that's about all we had for you guys. I know we went a few minutes over, but I want to thank everybody so much for attending today. It was an absolute pleasure presenting to everybody. If you have questions that you want to keep feeding on the Q&A communicator, Justin and I will still be answering them via the Q&A communicator, over the next few minutes or so. Just make sure we get everything answered for you guys. Other than that, like I said, it was amazing presenting to everybody today about all-flash storage. Hope you learned a lot, and be sure to reach out to us if you have have any questions or anything like that, or check out our website. A lot of helpful information there regarding pricing, different types of units, all that kind of good stuff. So, Justin, do you have anything else for the people before we head it on out?
Thank you for your time.
Awesome. Thanks so much, everybody. We look forward to speaking with you soon. Bye.